Assalamualaikum warahmatullahi wabarakatuh and a good meeting to everyone. My name is Ahmad Faiz bin Abdullah, final year student in Bachelor of Mechanical Engineering. The title of my project is Material Characterization of SA213 T91 at elevated temperature used in water tube steam boiler. The project is supervised by Professor Dr. Muhammad Hussein bin Ismail. There are 7 content that will be presented in this presentation, which are project summary, introduction, literature review, problem statement, objective, methodology, and preliminary result. This topic is to study the microstructure characteristic of material grade 91 being used in steam boiler at elevated temperature. The characterization of grain is important to understand in order to study the fatigue life effect. Grinding and polishing and etching are the process required to be done before going to either optical microscope or scanning electron microscope. The morphology of grain could be observed from surface grain and roughness in order to study the effect of fatigue grade initiation. The average grain size of void before and after fracture, and the distance between void. The result of this work will be used as input parameter for the G-curve. Steam boiler acts as a heat exchanger with a combustion chamber and a water reservoir that produce steam for outside usage. The focus of this topic is the material that will be used for water tube steam boiler. One of the material that used in water tube steam boiler is P91 or T91. SA213 P91 is a seamless alloy steel enhanced with ferritic and austenity. The P91 material are widely used in power plant, petrochemical, and nuclear industry for water tube. Until recently, the water plant industries have been using the enhanced ferritic steel such as material grade 91, 92, and 122. Based on the research that was done in previous study, the P91 is commonly used for superheated tube. In a study of P91 failure in superheated tube, crypt cavities with individual hole and chains of pore were found. The crypt cavities generate micro and macro crack of the failing tube microstructure. In another study, in an experiment of strain control low cycle fatigue test of P91, the material was exposed to high temperature for an extended time. Due to that, the crack initiation was found. Based on previous study that was done, the sudden increases of temperature that exceed the operating temperature caused the failure of material that was used in water tube boiler, which resulted transformation of grain microstructure. For FYP1, the literature studies and preliminary experiment have been done to obtain preliminary result for microstructure analysis. Literature study is done to evaluate any discussion or recent information related to the topic of material P91. The preliminary experiment that was carried out is sample preparation, microstructure analysis, and hardness test. First step in sample preparation is cutting process. Cutting process was done to get desired size of sample so that the sample can be easily handled. 2 types of grinding process was done. Rough grinding was done with sandpaper grade 240, 320, and 400. For fine grinding, the sandpaper that was used is grade 600 and 1200. For polishing process, rough polishing was done to remove the imperfection that the grind has left. For rough polishing, powder grade 5 and grade 3 was used. Each powder was done for 20 minutes. For fine polishing, it was done to leave a mirror-like surface using powder grade 1. For the last process in sample preparation, etching process was done. Etching process was done to reveal the grain boundaries, phase, precipitate inclusion, and variation in composition. The material used for etching process is kaolin number 2. The etchant consists of 60 milliliter ethanol, 2 gram copper chloride, and 40 milliliter hydrochloric acid. For microstructure analysis, 3 different lenses was used for getting the microstructure. We can see as the image was magnified, clearer microstructure was obtained. Then we proceed the experiment with viscous hardness test. These were the result of hardness test. The result for this preliminary experiment will be used to compare with the hardness level for the specimen after tensile and fatigue test. Viscous hardness obtained is different each time the test is performed. The average of HB is 204.58. Tensile test is where the tension of material was tested when tension is applied to the material until the sample is fully filled. Yield strength, ductility, strain hardening characteristic, Young modulus, and Poisson ratios can be obtained. Once the tensile test was done, the microstructure analysis post-experiment was taken to compare with the original microstructure. The tensile test will be done in FYP2. Fatigue testing is defined as the process of progressive localized permanent structural change occurring in a material subjected to the condition that produce fluctuating stress and strain at some point that may produce crack or complete fracture after enough fluctuation. In an easier understanding, by doing fatigue test, we can know the damage and failure of material under cyclic load. The test will be done in FYP2. In conclusion, some preliminary work was done so that students have general idea of performing experimental work and know the microstructure analysis. Even though the result obtained is not accurate, detailed experimental work can be done to improve the result that will be used for FYP2 in future. That's all for me. Thank you.